Hello guys, so this is my new video, and in this video we'll be talking about topological sorting. So as you can hear from the word, it is a kind of sorting but in a graph, and the name suggests topological sorting. This means we are sorting in some particular order, top order. And what is that order? For example, um, in a graph, in a directed graph, this kind of sorting makes sense only in a directed graph. The reason being that, for example, if I have a directed edge from A to B, this means A goes to B, this is an edge. The significance of A directed B, this means a directed edge between A and B means there can be many things. For example, I go from A is a city and B is another city. I go from A to B, but there is another sense to this. This means that A and B are some jobs that we have to perform, and if I perform A job, then and only then I can perform B job. This means the order in performing these two jobs is, if I perform A job, then I will perform B job, and then I will perform C job if there is B directed CH, and so on and so forth. So this means there is a sorted order in which I can perform these jobs. If there is a factory in which there are huge number of jobs, and I have created a huge graph means that if there is a first job that I can perform, after this there is another job that I can perform. This means 1 goes to 2, and then 2 has many other jobs that it can perform. So there are many edges going out from 2, then further there are many edges, and there might be some cycles also. So there are huge number of jobs, and I am a person and I want to find out that what is the relative order of these jobs that I can perform. So the relative order can be found by topological sorting, and this is quite easy because we know what is depth first search. If I start from a particular point in a graph, I can do a depth first search from that point to the whole graph, and then I can choose another point, and then I can do a depth first search again, and so on and again. And I can use some kind of a data structure, let's say a queue or a stack. I can use a stack, and as I do a depth first search from every node, I can push that node into the stack. For example, if I start from a particular node that is the root, then I start doing a depth first search. This means I accept the fact that yes, from this point I can do this job right now. Now I start a depth first search, I push this element into the stack, and then I say okay, I can do this job. Now I'm going to do the next job, which is the directed edge. Then I push that job into the stack, and so on and so forth. And in the end, I just pop each and every element out, and I see that okay, this is the relative order of these jobs. So this means that if I have an edge, just to summarize, if I have a graph, in that graph there are many edges, and they are of the form A to B, then this means that topological sorting means that it arranges these edges, all the edges of a graph, in such an order that it tells us we can perform every job in a particular order. This means that it kind of levels these jobs, that if I perform the first job, then I can perform the second job and third job, and so on and so forth. So let's start. So see, in the last video we talked about depth first search. So this is the code of depth first search that we implemented. This is the same code. This is not the same code, but it is the similar code. There's no difference. The only difference that comes when I implement topological sorting is we use a stack. So what we do is we define a stack here, S, and every function has a stack where we call a stack. We call the stack from every function. So definitely there will be an error here because I have not declared it here. So let's do that. I call everything in reference because these data structures are dynamically memory allocated, and because if I don't call them by reference, they will create copies of themselves, which can lead to memory access. Not in this program, but in programs where there are many functions. That's why I call especially vector, list, pair, int, these should be called by reference, because they will then create copies of themselves. Okay, yeah, again I will call a stack here, and then I will have to define a stack here, and then I will have to define a stack here. Yeah, so I think that's all. Yeah, and the thing is that now I will push s dot push the element x from which I am starting a DFS. So once I have done the DFS from x, the loop is finished. I push that element into the stack. So let's just run this code and let's see if it works. Sorry. If I have this graph, then the answer should be this. Yeah, correct. 10234. You can just draw this graph. This is correct. 10234. Right. Thank you. So this is topological sorting.